Welcome to SRM 520, Introduction to Statistical Computing with SAS. In this video, I'll cover the following topics. So I'll talk about various SAS statements and how to use them. In particular, I'll talk about set, put, drop, keep, lag, and then I'll talk about combining how to combine different datasets. There are several ways of combining datasets: concatenating, interleaving, one-to-one merging, match merging, and also appending, which I'll not discuss in this video. So let's start with set statement. So before we use the set statement, we need to create some data. Suppose we want to create the row dataset from the rowing_comma.dat data file. Recall that this is a comma delimited dataset, so that's why we're using the DLM option in the infile statement. And also notice that there are two variables, weight and the school, where school is a categorical variable. That's why we need this $in format. Now we print the data and it looks like this. So here I have only displayed first 12 observations because of space limitations. Now we want to use the where statement to select only the Oxford school. So we have our data set, which is row, and we're going to print from this data where school is equal to Oxford. Note that we have to put the Oxford string within the quotation, single quotation or double quotation, both works. And once we run this, we get these observations. Now we will use the set statement to create a new SAS dataset for Yale's observations. So we are creating a new dataset and we are calling it Yale, and then we are using the row dataset. So we are telling SAS to create the Yale dataset, taking observations from the row dataset, matching this condition that school is equal to Yale. So that's how we use set statement. So set statement can be used to create a new dataset, a sub dataset, or a smaller dataset from another dataset. Now you want to print the Yale data, and the data looks like this. The first 9 observations are from school equal to Yale, and the remaining observations were from Oxford. In this segment of the video, I will show how to use drop and keep statements. Drop and keep statements can be used to exclude certain variables from the SAS dataset, or to make sure only certain variables are included in the SAS dataset. So we will use drop or keep statements if our original dataset has many variables, but we want to create a smaller dataset containing only the variables that we are interested in. We can use drop or keep statements in order to drop variables or keep variables in our dataset. But if used intelligently, we can use drop or keep statements depending on whether we want to keep or drop a large number of variables. For example, if you want to keep a large number of variables, it's easier to use a drop statement to exclude only a few unwanted variables, so that you do not have to use a keep statement and to list all the variables that you want to keep. Also, if you want to keep only a few variables, then keep can be used to retain them in the dataset instead of dropping a large number of unwanted variables using the drop statement. So let's consider the contest data again. Read this data in SAS, and then we want to create a sub dataset containing only the variables for score 2, score 4, and score 5. Remember, there are 5 score variables: score 1, 2, 3, 4, and score 5. So here we are using the set statement to read the contest data and create a new dataset called contest2, and we are dropping score 1 and score 3 because we want to keep only score 2, 4, and 5. And when you print the data, you get a new data set with score 2, 4, and 5. Obviously, we want to retain all other variables, such as age, type, and date, and the name. Now, what if you use a keep statement instead of using the drop statement? So let's create a new dataset, contest3, and read the data from the original contest dataset and only keep score 2, 4, and 5. Can you guess what would the output dataset look like? Let's print it. And the output is this. Only those 3 variables that we used with the keep statement, and it has removed all other variables from the dataset. And often that's not what we want. So we have to use drop or keep statements intelligently in order to minimize our work. Now in this segment of the video, I'll show you how to combine different SAS datasets. There are several ways of combining datasets, such as one-to-one merging, concatenating, appending, interleaving, and match merging. Let's talk about one-to-one merging. So let's talk about how one-to-one merging works. Consider 2 datasets, A and B. A has 2 variables and B has 2 variables. And they have a common variable called num. And variable A is unique to dataset A, and variable B is unique to dataset B. And notice the numbers 1, 3, 5, 2, and 4. These row identifiers are also unique. Now, when you combine these 2 datasets using one-to-one merging, the merged dataset would look like this. So there is no 1, 3, 5, but only 2, 4, and there is no A3 here, only A1, A2, but B1 and B2 are retained. In many situations, we may not prefer to use such merging, but there are other options available of merging these 2 datasets and retaining all the information that we have in these 2 datasets. So in one-to-one merging, the new dataset contains all the variables from all input datasets. The new dataset here contains all the variables that we have in the input datasets. If there are variables that are common, that is, the variables with the same name, the values that are from the last dataset overrides the values that were read earlier. So in this case, we have a variable that is common in both datasets, and B dataset was considered to be the last dataset of the second datasets. So that is why the values in number in this num variable in dataset A gets overwritten by the values in the later dataset, which is the dataset B. So that is why we have 2, 4, but not 1, 3. Also, the number of observations in the new dataset is the number of observations in the smallest original dataset. In the new dataset, we have 2 observations, which is equal to the number of observations in the smallest original dataset, which is the dataset B. Observations are combined based on their relative position. That is, first observation in one dataset is joined with the first observation in the other. So in this case, this observation, the first row of dataset A, is joined with first row of dataset B. The data step stops working when it has read the last observation from the smallest dataset, and that's why we do not have the third row in the merged dataset. So here we are creating the 2 datasets, dataset A and dataset B, and we want to use the set statements in order to combine these 2 datasets using one-to-one merging. So we are creating a new dataset, data 1-to-1, set A, set B. So we have to use set statements for all the datasets that we want to combine together. So in this case we have 2 datasets, so that's why we need 2 set statements. Now if you print this one-to-one merged dataset, we run the print statement and we get the output as expected. Here's an activity for you, so you can pause the video and practice the activity. Let's move on. In this segment, I'll talk about concatenating. This is another way of merging two or more datasets. In concatenating, the process appends the observations from one dataset to another dataset. In other words, it stacks the datasets. You use the set statement and list all the datasets you want to combine after the set statement. You have to use only one set statement, and you list all the datasets after this set statement. Unlike one-to-one merging, where we had to use as many set statements as there were datasets. Here's a schematic picture of how concatenating works. Suppose we have two datasets, data 1 and data 2. In data 1 we have a variable var x, and in data 2 we have a variable var x. Because the variable names are the same, when we concatenate, these two datasets will be combined into a single variable called var x, and the data will be stacked. So x1, x2, x3 all the way up to x5 goes here, and the second dataset is stacked under the first variable. So this is the combined dataset. So now we will use the A and B datasets that we have created earlier to see how concatenating works. So we have these two datasets, and we are creating a concat dataset by issuing the statement called set AB. So we are concatenating A and B. And when you print the concat dataset, we get this combined dataset. Now notice that because num and num, the variable names are the same in these two datasets, these values were stacked under the same variable called num. Because var A was in data A only and var B was in data B only, we have these two variables in the combined dataset, and these values are missing values. Now we want to create a new dataset called C, and we'll concatenate with A, B, and C. So we have A and B previously created. Now we create a new dataset C in the same way, and the dataset C looks like this. We want to concatenate using the set statement ABC, set ABC, and when you print it, it will give us the merged or combined dataset. Again, the values that are not available in other datasets will be missing. Here's an exercise for you. Here's an activity 2 for you. Let's move on. In this segment of the video, I will talk about interleaving. This is another way of combining datasets. Interleaving is a way to combine datasets similar to concatenating. The combined dataset has the same number of observations as concatenated datasets. Interleaving works the same way concatenating works. The difference between concatenating and interleaving is the order of the merged data. Remember, in concatenating, the data were merged row by row. In interleaving, we use a by statement to guide the order of merging. So we'll use the A, B, C datasets and combine them by the num variable. Remember, interleaving works by using a by variable. So because of the presence of by variable or use of by variable, all of these datasets must be sorted by the by variable, which is num. So that's what we're doing here. We are sorting all of these datasets by the num variable. Now to interleave, we use the same syntax as we used in concatenating. So we create an inter dataset using the set statement ABC by the by variable, so by num. So this will create the interleaved dataset, the combined dataset created from combining A, B, and C datasets. Notice that when we use concatenating, we did not have this statement, but in interleaving, we have to use a by variable. The by variable is used to guide the order of merging. Interleaving versus concatenating, what's the difference? As mentioned earlier, the main difference is how the merging works. In interleaved data, notice that the columns are merged by the ordered num variable. First, the ones were merged, and then the twos, and then the threes, fours, and fives. There are only 1 4 and 1 5, so we have only 4 and 5, one instance of 4 and 5. Whereas in concatenating, the data were simply stacked because there is no grouping variable. In this part of the video, we'll talk about match merging. Match merging combines two or more datasets using merge statement and a by statement. So this is more advanced than interleaving and concatenating. In match merging, datasets must be sorted by the by variable, which is common to all the datasets. So in match merging, we have to have a variable that is common to all the datasets. The merged dataset will have the number of observations equal to the number of observations that have common by group values in each dataset. That is, the observations that are common in each dataset by the by variable, plus the number of unmatched by group values from each dataset. That is, the combined dataset will have the matched rows plus all the unmatched rows in each dataset. So here's an example. We have two datasets. We have one dataset with column ID, which is exactly the same as the column in the second dataset. We want to merge these two datasets by matching with the ID variable. When we do this, the resulting dataset looks like this. These two variables gets combined by the matching ID variable. So 4112 had score 87 on test 1 and score 85 on test 2, and that's what we get in the combined dataset. So here's the match merge steps. First, the datasets must be sorted by the by variable. Then we use both a merge statement and a by statement in a data step. So in the data step, we have to use merge and the by statement. So here's an example. We have two datasets. One is for the midterm scores and other is for the final scores. In the midterm scores dataset, we have two variables, ID and test1, and the final scores dataset has two variables, ID and test2. Notice that the datasets are not of same dimension. One dataset has more observation than the other. And also notice that we have different variable names, and also we have a common variable that is common in both datasets. In particular, notice the observation number 5 in the midterm dataset, which is not there in the final score dataset. And we will later find what happens to this row when we match merge these two datasets. So first we need to sort the dataset by the ID variable, and we're doing the midterm dataset and sorting them by ID, and for the final dataset sorting by ID. And now we combine these two datasets with the merge statement. Notice that we're not using a set statement, we're using a merge statement instead. So data combined, merge midterm and final by the ID variable. So ID variable is the variable by which the midterm and final datasets are sorted. So once we print the dataset, we get the final combined dataset. Notice what happens to the row whose ID number was 4006. ID 4006 had a score of 82 on test 1 but didn't have a score on test 2. So in addition to displaying the matched rows, the combined dataset is also displaying the unmatched row in this case. So match merging examples demonstrated in this slide are simple and straightforward. However, match merging can be complex depending on the source datasets, common variable or variables, and the output dataset that you want to create. After match merging, you may need to further process the data to remove unwanted observations, that is, unwanted rows of data, or to remove missing observations that the match merge process may create. Here's an example for you to practice. And here is activity 3 for you. That's all for today. Thanks for watching.